Hello, if you click this link, you must be interested in building a Jeep hoist in your garage for your hardtop to make taking the top on and off easier. So listen further and I'll give you all the information you need to build one of your own. I want to take just a quick moment and tell you why I wanted to build one of these and some of the goals I was looking to accomplish. And then we'll pop out to the garage and I'll give you a walkthrough of how the system works. And then we'll swing back here to the desk and we'll talk through the design in a little more detail. So before I decided to build one of these, I watched a number of YouTube videos, and for one reason or another, all of the videos that I reviewed just didn't seem to meet the needs for my situation, and so I decided to figure out how to build one for myself. Some of the reasons I didn't like some of the existing designs were that my ceiling in my garage has a two-story above it, so I can't put a winch up in the ceiling. Some of the other solutions were really expensive or they were a mobile cart that seemed quite flimsy and again, pretty expensive. And then the other solutions, sometimes they had a single point of mount to the ceiling. And to me, when that lifts up, that's going to give it the opportunity to spin. And that didn't seem like a good idea to me. So what were the goals of me building this hoist? Primarily, the first and foremost was so that my wife could lift it and take it on and off without my assistance. This means it had to be a powered hoist or powered by a winch or an electric winch because it couldn't be a manual lifting process. Another thing I was looking for was for a system that was very safe and secure. It had to be able to hold the hardtop up there without risk of falling. We spent a lot of money on our Jeeps, and we didn't want it to fall and either damage the hardtop, damage the Jeep, or even land on a person. So that was definitely a priority as I put the design together. It couldn't be expensive or in the way. So we had to have something that would lift it up out of our day-to-day lives and not necessarily be in the way. Didn't want to spend a bunch of money on it. And I wanted to be able to just use common parts from your normal hardware store. So overall, the solution is quite simple. So all the parts in the design will be listed in the description, but again, they're all relatively available at any common hardware store. With that, we'll jump out in the garage and take a look at how the system works. Now that we got the top ready to come off and the hoist or lift is all the way up at the ceiling, we need to grab the controls and lower it down. And so the control's got an up and a down button. And so with that, we will press the down button and see it lower. Okay, now that we've got that lowered, we can pull down on these straps and unclip them from the carabiner in the front. We will take the strap and we will go inside of this strut on the rear so that we're not strapping it up by this strut. We will toss it to the front. Come around, take that same carabiner and hook it back up here. We'll go around to the other side. We'll do the same thing. Again, unhook the front strap, go under the strut for the back window, hook it back up to the front, and you're now ready to lift. Okay, now that we're ready to lift, we're going to actually do this in two steps. We're going to raise it up a little bit to make sure that the winch line here is lined up appropriately and it's going to lift by the proper point. And then we'll run it up the rest of the way. Grab the controls, lift it up. And stop when we get just a little bit of tension on here. You want to make sure that this strap is laying flat here and laying flat against the door here so that it's not curled up and putting additional pressure, too much pressure in one place. We'll check that on both sides. Now that we've got the straps all checked to make sure they're laying smooth, we've got the entire hardtop disconnected. We've got the electrical and the water disconnected from the back windshield. We'll grab the controls and run it the rest of the way up to the ceiling. And with that, your hardtop is lifted and you're ready to jump in the Jeep and drive away. Now we're going to demonstrate how to lower the Jeep hardtop back down onto the Jeep. And for that, you've already got it off and you've got it hanging from the ceiling. And so we'll grab the controls and we will lower the hardtop. Obviously slowing down a little bit as we get nice and close, and there's still a little bit of tension on the wire here holding some of the weight while you shift it into a final place. And as you can see, just kind of wiggle it a little bit and it falls right down onto the studs to line everything up. And now everything's lined up, and so we can lower the winch the rest of the way. And with the winch lowered down the rest of the way, we can unhook the carabiner here. We can pull it through the back and hook the carabiner back up. We will do the exact same thing on the other side. Okay, and now that once that is all hooked up, we are clear from the hardtop and we are ready to run the lift back up for storage without the hardtop on it. And you're all set to go ahead and put the screws and the hardware back in, reconnect your electrical and your water, close everything up, and you're good to ride with the hardtop on. Okay, there's a few things to note while you're operating the lift. The first that probably seems a little bit odd is why the weights are tied onto the rear carabiners on both sides. And the reason for that is if you lower the lift without anything connected to it, then the winch unwinds itself, but the ropes aren't heavy enough to pull it down. And so my wife is rather short and she can't reach up and grab the ropes to pull them down on her own manually. So by adding a little bit of weight to the rear carabiners, as you release the lift and lower the lift, it'll come down so that she can reach the ropes and then hook up the Jeep by herself. The other thing to note is that when you're running the winch in and out, there are some thresholds where you want to start and stop the winch and you don't want to go beyond. And so there's a mark on the ceiling that I put so we know exactly when to stop the winch. And then when you let the winch out, you want to make sure that you don't go up into the first set of pulleys, which we'll look at the design. But so you want to keep the lifting distance between the winch on the wall and the winch on the ceiling, or wherever your 2 points are that winch can go out in between. And so I'll demonstrate that now. So as we're going to let it out here, you'll see that the weights will pull down the ropes. And we can run the winch out until it reaches about where those first set of pulleys are, which gives you plenty of room to bring the ropes down and strap the Jeep hardtop up. When you're rolling it up after the hardtop is all connected up, then when you run that winch in, you only want to get to the next pulley closest to the wall. If you go too far, then the winch head will get caught in that pulley and it'll try to pull that pulley out of the wall. So you just got to be careful when you're running it up and down to not lower it too far or raise it too far. And we made that easy by knowing go between the pulley on the extension and the red line that we marked on the ceiling on the full when you're rolling it back up. So to give a quick walkthrough of the lift system itself, we have, starting with the winch that we've got mounted on the back wall here. This winch is from Harbor Freight, and it is an AC powered winch, so there's no DC 12 volt wiring like you would on a normal winch attached to a car. But we just basically ran the power down and over to the outlet there. And then the second cable that's coming out of there is a cable that is connected to the remote control to operate the winch by going up and down. As we come out of this winch, which is mounted to a plate on a board, which is on the shelf here, if in your garage you don't have a shelf to mount it conveniently like mine was, you can certainly mount the winch up in the corner mounted to the wall there.
or really even just against the wall, or really any location where you can get some extension on that winch. So the winch line that's built into the winch goes up to the first pulley in the corner. And we'll come back to that little strap that's hanging down in the front of it. But the winch line just goes up to that 90-degree pulley and then comes along here to the first set of pulleys. This first set of pulleys supports the rear carabiners. And so if you look at where those attach, those first set of pulleys come over here to the back mounting point and then down to the rear carabiner, as well as the pulley on the left doing the exact same thing over to that pulley and then down to the weight, as well as the other two sets of ropes that are mounted to this winch head here go to the front two pulleys, which are mounted by an eye hook. They share that same eye hook, the two pulleys, and one of them goes off to the right here to that set, and then one goes off to the left to the front left set over there. And then they go down to their carabiner to attach to the front. When we look at each of the corners that support each of the carabiners, and we're looking at the back one that's got the weight on it at the moment, we look at there's two eye hooks associated with each corner. There's one eye hook that goes up into a stud here, and then a second eye hook that goes up into the stud, and they both have these quick link adapters. One of them attaches to this ring, the other one attaches to the pulley. The pulley and this quick link and this eye hook do the bulk of the work all of the time. I'm extra cautious with the weight of this hardtop and the potential for it to fall down on top of the Jeep, that I like to put a safety measure in here. And so if for some reason this pulley or this eye hook gave out, this ring would catch the rope and therefore not allow the hardtop to fall down onto the Jeep. And so each of the four corners have one of those very similar rings that provide us a safety. Now, the other part that we did was we attached another safety up on this corner here, that if that pulley ever gave out, the whole system would come crashing down as well. And so I've put a lot of weight on that pulley. It's not going anywhere, but for safety's sake, I decided to mount an eye hook on each side of that pulley and then take the same rope that I used to hoist the Jeep, tie it in a loop, and then use a square knot in the middle to tie it together. And so if for some reason that pulley ever gave out or failed, the rope would fall down and be caught by that backup catch there. Okay, I want to just show another angle here. This is looking from the garage door in, and you'll see that there's the eye hook here with two pulleys attached to it that connect to the front ropes that support the Jeep hoist. And then from that, those ropes go to the front of the winch, where I've put a loop on the end of that winch that we tie the ropes to. So here we are up at the top. I'm standing right next to the winch here, and I want to pull down this winch and explain a couple things about how it's attached. So as these four ropes come in to attach to the four corners, what I did was this winch had one of the normal hooks that comes on the end of a winch, and you could leave that on there and it would work just fine. I chose to actually take a hacksaw and cut that off. And then I purchased one of these, I think it's called a thimble, but it loops the rope back on itself, and then a couple clamps to hold the rope down there. And so there's no opening, and therefore the ropes can never come off. But the normal one that's on here would probably work just fine. Now for each of the ropes that I attached here, all I did was I looped them through the loop here, and then tied a bowline knot on here, which the bowline knot is very creative because it allows you to adjust how much ever loop you want on here. So you can create this loop as big or small as you like, and the weight of the rope actually tightens the knot. So it's a great knot to use for this purpose. So one of the things you're going to want to do before you start attaching things to ceilings is figure out which directions your studs run in the ceiling. And so for that, typically you find a stud finder. I'll spare you the joke of my wife being a fantastic stud finder. And so you put it against the ceiling. There's various kinds of stud finders, but as we slide it back and forth here, you'll find that my studs run this direction along the ceiling. And so that allowed me to attach the eye hooks for the back points along the same line. And then the front ones also attached on the same line. And then I had to find two studs in the middle in order to attach the front two pulleys. Now,
regardless of how your studs are oriented, one way or the other, you can still make this work. And the way you make this work is that if your studs were running the other direction and they were running this way, you'd simply just put a 2x4 crossways on the surface of the ceiling, and then you can paint that to color your ceiling so you wouldn't see it. But you could run that crossways across your studs and then just simply mount the eye hooks into that 2x4 that you just installed. The other thing I want to show is just a couple of the knots that I use. Use this to attach it to the carabiners, as well as to the eye hook of the winch where all the 4 ropes come together. And so they call this a bowline knot. So basically you take the knot and you just make a loop out of a single rope. And why this knot's good is it allows you to create a loop in the end of a rope. And if you put something through the loop, then obviously it attaches the rope to that. So create a loop like this and make it as big or as small as you like. Then you take the end of the rope and you feed it from the back through the loop. Then you go behind the wire and then simply go back down through the loop. And then when you pull that, it allows you to take that and tie the knot tight. There's lots of videos online that show this as well, so just a very quick demo here. Again, the other nice thing about this is that it allows you to adjust the length of the loop here, and so you can just feed this line in and then readjust the knot, and it creates a different size loop. The other knot to go over just real quick, which is the knot that I used for the safety around the pulley that's just above the winch, is a square knot. And so to do a square knot, basically, the reason a square knot's good is to attach the ends of 2 ropes together as opposed to making a loop in the end of a single rope. And so to do a square knot, you take and just make a simple loop on one side of the rope, and then you take the other rope and you feed it through the inside, and then you wrap that rope around behind the knot, the loop, and then you push it back through the other side. So basically you go through the loop, around the back, and then back through the other loop here. Then when you pull that tight, the weight pulls the knot tighter and tighter, and it creates a square knot. One thing to note is these carabiners have the main section here where they unclip and you hook the ropes, the straps that hoist the Jeep up. But they also have this circle here where you push the rope through. And the rope that I bought is 3/8 inch rope, and these carabiners are a little bit small, and so you kind of have to stretch the rope to get it through this hole here. It'd probably be a good idea to buy a carabiner that's just a little bit bigger. It'd make it easier to loop that rope through, but I was able to make it work with a little bit of effort. One other thing I ran into as I was assembling the system is these pulleys that I bought. It's a little hard to show with the focus of this camera here, but if you look down inside of the pulley here, you'll see there's a little bit of metal hanging down inside of that pulley, and as the rope goes through it, sometimes they get caught on that pulley. And so what I did was I just took a basic metal file and ran it in here and ran it back and forth inside of the pulley there to smooth it out, and that created a nice smooth surface inside of the pulley there. And then the rope pulled through just fine. Just something to note that if you don't file out that metal piece, it'll catch on the rope every time the rope continues to go through there, and it might eat away and chew at your rope over time. Back here to the desk, I want to go over just something really quick on how pulley forces work, and then pull over the design and look at the design itself and some things you wanted to kind of take into consideration as you put your solution together. So first off is a very basic concept with a pulley. So when you're looking at a pulley and you've got a 100-pound weight here, and you pull down on a pulley 180 degrees, so you pull it straight down, the force on the rope and the force on the weight and the force on both sides of the pulley are both 100 pounds. And so when you think about the weight that's on the actual axle of the pulley itself, pulling in the other direction is actually 200 pounds. So the weight that you're trying to lift when pulling 180 degrees in the opposite direction, in other words, the weight is going up and your pulling force is going down, the weight goes by 200% of the weight you're trying to lift. And that's not the weight on the rope, that's not the weight of the object, that's not your lifting weight, but that's the amount of weight that, or pressure or force that's put on the pulley itself in the opposing direction. So this pulley would have to be rated to handle 200 pounds if you're lifting a 100-pound weight if you're pulling at this angle. And so on my design, you see that there's the one pulley up near the ceiling that's a 90-degree pulley. And so for the consideration of that, if you're lifting 100 pounds, the weight on the rope and the weight that's being pulled is the full weight. That doesn't change. That's still 100 pounds. But the angle at which the weight is on the pulley does change because the angle is being pulled at this diagonal direction here. And so at a 90-degree angle, it puts 141% of the weight you're being lifting on the actual weight of the pulley. So this pulley would need, in this scenario, would need to be rated for 141% at least of the weight that you're trying to lift. And so this third drawing over here gives you a lot of different variations around the angle at which you're trying to lift. And so this gives you a good idea of how the weight increases and how the rating of the pulley needs to increase as your weight and or the angle that you're lifting at increases. So just real quick to break this down, if you've got 100% load on the rope or the system, that 100% is the same no matter what the angle is. The weight on the rope does not change. The weight on the angle does change. But as you pull that angle steeper and steeper, you'll see at 90 degrees, you'll see that the weight pulled is 141% of the weight that's being lifted. At 60 degrees, it's 100% of the weight that's being lifted. So if you have a 60-degree angle, then you're lifting exactly 100% of the weight and 100% of the angle of that pulley. Now, if you flip that and go up to a 120-degree angle or a sharper angle, and this is, in my design, this is the case for the two surface mount pulleys or the rear pulleys attached to the rear of the hardtop. Now you're pulling against 173% of the actual weight. So this pulley needs to be rated for 173% of the weight being lifted. And so if you take that to its opposite extreme, like the example we started with, if you're pulling at 180 degrees, then the weight on the rope, again, stays at 100, but the force or axle force on the pulley doubles to account for the weight on both sides of that rope. Now, to look at the design of my hoist out in the garage, the Jeep hardtop is down here at the bottom, and these four dotted lines are the lifting ropes, or say the vertical ropes that pull it toward the ceiling. And then all of the solid lines are horizontal ropes. These are ropes that lift the weight once the rope has hit the ceiling and runs along the ceiling. And so if we look at the hardtop, doing some searching, hardtops were about 150 pounds, but I did a weight measurement on each of my corners, and mine was about 30 pounds. So in total, my hardtop was around 120 pounds, and mine is a JLU. And so I don't know why a hardtop would be heavier than that, unless you've got a roof rack or something along those lines. But they said somewhere around 140, 150 pounds is kind of the most. But again, mine was a little bit lower than that. And so what you do want to make a very important note up here at the top, which is that we make sure that all the equipment is rated for 2 times the working load. So most of the devices that you see that you'll buy, all the components, have a working load rating. And so you want to figure out how much load is going to be on that part of the system, and then you want to double that to make sure that you're within safe operating conditions. And so a couple things to look at here in terms of the pulley weights. The four corners here are all the same, but I've just got one example up here. And so the lifting weight on this pulley is about 30 pounds is what we're pulling up. And so this entire rope, the entire distance, will only ever have 30 pounds of weight on it. That goes for all 4 of these ropes. And so this rope is weighted at I think 225 pound load rating. So more than enough weight there. And so this angle coming up from the floor and then turning over toward the center pulley is about a 90-degree angle. And so as we talked about, that's 141% of weight. So you take 30 pounds times it by 141%, the weight on this pulley is around 42 pounds. Now these pulleys are weighted at a working load of 110 pounds. So we're well within the doubling rule there. And then if we look at these center pulleys, these pulleys here are really more of rope guides. They don't really hold a whole lot of weight. And back to our previous example, when you get a 120-degree angle here, the weight on the rope is, or the weight on the axle is actually pretty light. And so it's around 100% of the weight that's being lifted. So the weight on this pulley is around 30 pounds. And again, this is rated at about 110, 125 pounds. So we're good there. The ropes have about 30 pounds of weight. And then if you look at these center pulleys, the ones that I've actually upgraded to a 440-pound surface mount pulley, the reason I did that is because there is such an angle on this rope. And it really depends on where your ceiling studs are. Again, mine run horizontally here across the Jeep hoist. But it really depends on where these things are mounted in your ceiling based on where you either put in a 2x4 across the studs that would run the other direction, or when you attach them to the studs directly, how much of an angle is on these ropes. And that's why I gave you the other chart that kind of shows how much force you need to account for here. But I mean, worst case, to make this very simple, is that even if you're pulling at 180 degrees, if each of your lifting corners is around 30, even 40 pounds, you would have at very most, you'd have 80 or 90 pounds worth of weight on the pulley at most. But again, I wanted this to be safe and secure. So what I did was I upgraded these because I also did not want to rely on the eye hooks, because all these purple pulleys here are mounted by eye hooks with quick links in the ceiling. These ones are screwed with 2 screws directly into the ceiling, which I'll show you a picture of. But so they're more secure and directly attached. They're not dependent on the eye hooks. And so that gives us a much higher working load of around 400 pounds or 440 pounds. And if you calculate the load here at even 173% because of the really sharp angle, I'm calling it about 60 degrees, that still only is about 51 pounds of working load there. So plenty of room and safety to spare. Working over toward the winch side of things here, this one is the one that's got the most load on it because it is a combination of all 4 ropes are aggregated together at the winch point, and it's at a 90-degree angle, which means it's 141% of the load. So if you figure your load is 150, 120 pounds, depending upon your hardtop, you take that by 141% because of the angle, you're looking at around 170 pounds of load on that, which is a 440-pound pulley, so more than capable. But there's screws that attach it into the wall, and the wood in the wall, the beam. But I wanted to be extra sure here, and so that's why I put the safety rope underneath with 2 eye hooks around it. Back to the operating and this max lifting distance. So the head of the winch has the ability to rotate from these front pulleys all the way back to this corner pulley. So that would be your lifting distance. I didn't measure this, but it's rather far. It's probably 4 or 5 feet here that allows you to lower it all the way, attach, and then pull it back up here. Again, the amount of weight that the winch itself is pulling is the full weight of the hardtop. The pulleys doesn't matter. It's the actual weight that's on this winch cable. And so that's around 120 pounds in my case, but at most 140, 150. And so again, the electric winch has the remote control that comes off of it, as well as the AC outlet that we plug in. The last point on this sheet is really kind of around the knots. And these are easily available online as well, is just kind of giving you a quick walkthrough on the different steps to tie the knots, so that you know that everything is securely attached together. With that, you've seen how the system is designed, some of the goals I was looking to accomplish. I think it meets all the needs for me, and hopefully this video will give you the tools that you need to go build one for your situation, and or wife, if that's helpful, to be able to let them take the hardtop off by themselves. Again, I'll put all the parts down in the description. And as usual, anytime you could like or subscribe to the video, that certainly helps me out. But with that, good luck building, and if you've got any questions, put them down in the comments, and I will respond and try to provide as much feedback as I can. I appreciate you watching. Thanks.